Hello and welcome one and all to the wonderful world of physics. Currently we are talking about the dreaded graphs. Nobody likes graphs. They are wonderful when it comes to interpreting information at a glance, but at their first introduction, nobody really likes them, the poor things. So before we get into converting from one graph to another, I wanted to briefly talk about, again, looking at that data from a visual perspective and being able to interpret it. So last time, as I was telling the stories, we drew them. So this time we're going to go the other way. This first graph here is a speed versus time graph. So that means I'm not looking at direction. I'm just looking at what am I doing. So if a question were to ask me to describe the motion of the object, car, ball, bug, whatever, from what I see here, the first thing you notice is that the object is going some speed. This is a constant speed. It's not zero. I know it's not zero because, well, zero's down here. So this is some number. So my object is moving at a constant speed. Then my constant speed is decreasing. A change in speed is called an acceleration. So I am decelerating, but we don't like that word, so this is going to be a negative acceleration. It is slowing down at this point here. At this point here. Then, down here, I have no speed. There's my zero. My object has, in fact, stopped. Now notice I haven't said anything about where my object is going. If he's going up, down, left, right, does not matter. Speed only looks at how fast are you going, not which way. It's not till we get to velocity that now we are talking about displacement instead, and direction matters. I'm going to keep to my usual convention where up and right are positive. So again, describing the motion of this object. This object starts from zero. It starts from rest. Then it accelerates. This is a positive velocity. This is a positive slope to this line. Y over x, change in y over change in x. So since this is a positive slope, it is a positive acceleration, which tells me I am speeding up forwards in the positive direction. Speeding up forwards, moving at a faster pace with each giving moment in the positive direction. Then I heat whatever my coasting speed is, and I go a constant velocity. Notice my direction is not changing, nor is my magnitude. My speed is not changing. Then, at this particular moment in time, my object begins to slow down. We are decelerating up. Don't like that word. So, this is a negative acceleration, a negative slope, and I am slowing down. Again, still in that forward direction. So, think of this as you were at a stoplight. You accelerate your car as the light turns green. You go a constant velocity down the road a little ways. You see another stoplight. You start slowing down, and here's the red light. Let's look at one that involves that negative side that we don't like. Again, we would need a little bit more information to know specifically what the object is doing, but if we were just asked to describe the motion of this object from what we see. Once again, because we start at 0, 0, I know we are starting from rest. My object is accelerating, positive slope, positive side of the graph, so we are going faster forwards. I hit my coasting speed, so this is constant velocity, and then I start to slow down. So this is a negative acceleration. We are slowing down, but again, we are still going in the forwards, the positive direction. Here is the weird spot. So remember, positive and negative tells you direction right there. First off, we hit a velocity of 0, so my car stops. Then it proceeds to accelerate, go faster, but in the negative direction. So if we think about the numbers on this number line here, even though they are negative, they are getting bigger. So I am accelerating. I am going faster, but in the negative, in this case backwards, direction. It would still be labeled as a negative acceleration because I am moving in that negative direction. So it's a little counterintuitive to have a negative acceleration and a negative acceleration, but this is a deceleration, a slowing down, which gives us a negative acceleration. This is going faster, but in the negative direction. So be careful. Take each piece of your chart on its own. Don't just assume because the lines appear to connect that they don't tell you something new. It just says D. So on the get-go, I might not know exactly whether this is distance or displacement. However, because I have positive and negative, that implies direction is important here. So that means I am in fact looking at displacement. So, displacement graph. We are moving forward at a particular clip. We start at whatever our beginning is. So we move forward at a particular clip. We think, oh, I forgot something. So we are again moving, but we have turned around. So now we are going backwards. As my direction, or as my displacement decreases, as I head back towards zero. At this point, I am moving away from my starting point. So right here, I am back where I began. I am back to my starting point. However, I keep walking in my backwards direction. So were there numbers associated with this graph? If it were to ask you how far you are from your starting point, this whole piece up here has canceled itself out. We walked away, but then we walked back. And so I am back to zero. This is the leg that actually took us away from our starting point. Couple of more graphs. If we look at this graph here, this acceleration one over to the left. Since this is acceleration, remember we could have negative acceleration mean multiple things. So again, there are several possibilities for this graph because it includes that negative piece. So this bit right here tells me I am going faster. And I am going faster in the positive direction. So it is above the line. I am moving faster. It is in the positive direction. The second possibility, and again, this is weird. My second option is that I could be slowing down in the negative direction. Easy way to remember that. Negative and a negative makes a positive. Faster in the positive direction, that's two positives. So I have two options already on my graph. I would need more information to know exactly what my object is doing. Here we have a constant velocity, constant speed, no change there. That is a zero acceleration. It can only mean one thing. Down here, again, with that negative line, I have two options. We could be decelerating, slowing down while going forwards, or we could be speeding up while going backwards. So, negative and a positive makes a negative, positive and a negative makes a negative. Acceleration graphs are tricky. So please take your time and think all the way through them before you start running into things. This graph right here is really funny looking. And the whole reason I included it is so, again, you could see what acceleration looked like on a distance or a displacement graph. This curve right here, I am covering more distance per unit of time. So this here means that I am moving forward. So there is a speed or a velocity. We are moving. In a forward direction, not only are we moving in a forward direction, we are moving faster in a forward direction. So this implies that we have a positive velocity, a positive speed. I'm moving forward. It also implies a positive acceleration because we are moving forward faster with each given moment. This line here, I am no longer moving faster with each given moment. Instead, I am simply increasing my distance at a steady clip. A straight line like this, our sloped line, indicates once again a positive velocity or a positive speed, but there is no acceleration because I'm covering the same amount of ground with each passing moment. Here, once again, the amount of ground that I am covering is different for each passing moment. I am still moving forward, so it is still a positive speed or a positive velocity. However, I am slowing down. So there is our negative acceleration. As it turns out, that explanation took a little longer than I thought. So our translating from one graph to another, so from a velocity to a distance or vice versa, is going to have to wait until next video. I'm sure you are so bummed. Hope you can cope with the loss. So either way, the next video we'll get into converting graphs. Thank you for your patience and best of luck.